This lesson is a review of a previous course, and in this lesson, all we want to do is just use the slope formula to determine the slope of a line given 2 points. Now, remember the slope formula is this. So this is the slope formula. I'm going to write slope formula down. And so basically, if you're given, let's just kind of draw something like this. If you're given 2 points on a line, and let's say this point here has coordinates x1, y1, and this point has coordinates x sub 2, y sub 2, and you want to find the slope of that line, then the formula is this. Remember, the symbol for slope is lowercase m, and so basically all you do is subtract the y coordinates from each other, and the order matters. So remember, when you're dealing with slope, the order matters. It's very important that you get that order correct. So if you put y2 first, if you start with the second y coordinate, then in the denominator you must start with the second x coordinate. All right. So if you use this point here first, then for the denominator you got to use that x coordinate first. Okay. So the order matters. So that's something you have to remember from a previous course, and most of you probably do, if not all of you. Now remember, slope is rise over run. You can also consider this as rise over run. So the change in y coordinates, change in y, divided by the change in x. All right. So remember, change in y, change in x. That's the idea of that difference. So notice I'm subtracting the y coordinates from each other and subtracting the x coordinates from each other. Okay, so that's a slope formula. So let's kind of remind ourselves how we use that formula. So let's look at this first example. So the directions will say something like find the slope of the line containing these 2 points. All right, and so number one, let's suppose we had -2, 5, and we had, let's say, 6, 8. All right, so -2, 5, and 6, 8. And so what I want to do first of all is kind of look at the graph of this. So I'm going to go ahead and plot the point -2, 5, and 6, 8. Now you don't have to graph this to determine the slope. You just use the slope formula. All right, but I just want to remind you about something from what you've learned in the past. So if I plot those 2 points, and our 2 points were -2, 5, and 6, 8. So if I plot the point -2, 5, and so -2, 5 is here, all right, and then I'm going to go ahead and just label this -2, 5. And if I plot the point 6, 8, 6, 8, let's say is here, 6, 8 right here. All right, I'm going to plot the point 6, label the point 6, 8, and I'm going to go ahead and graph this. And if I graph this, I want to show you what basically we're looking at. So we have this line that I'm trying to find the slope of. So this line here. All right, and so using the slope formula, and so the slope formula is this. I'm going to come back to this in a little while. The slope formula is this. So remember, it's y2 minus y1 over x2 minus x1. Many students find it helpful. Many students find it helpful to label these points. So if you call this the first point, then we'll say x sub 1, y sub 1. So here's the x coordinate of the first point. Here's the y coordinate of the first point. And then we'll call this x sub 2, y sub 2. And then all it is just a matter of you substituting those numbers into the formula. But remember, the rise, the change in y, is the numerator. All right, so the y's are in the numerator, the change in x's are in the denominator. So we're going to say, I'm going to start with 8. So we're going to say 8 subtract 5. Now, since I started with 8, I must start with 6. The order matters. Order matters. So we're going to say 6 subtract a -2. Simplifying the numerator, 8 subtract 5 is 3. And then 6 subtract -2 means 6 plus 2, which is 8. So the slope is 3/8. All right. Now notice, I want you to notice something here. Okay. So remember, in one of the previous lessons, we talked about rise over run also. And so But we talked about rise of run in terms of slope and intercept. What I want you to notice is this. You see this point here? Remember the slope is 3/8, right? Slope is 3/8. So remember, slope is rise over run. So from this point, if I go up 3, watch, 1, 2, 3, and then since my run is positive, I'm going to go to the right 8. So let's do it again. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So you get that point. All right. So the slope of this line is 3/8. Now, here's something I want to remind you of. Okay, so listen carefully. Since the slope is positive, the line rises. So the line rises from left to right. Okay, so notice our line is rising, right? So as I go from left to right, our line is rising. And I want to remind you of something. So in a previous lesson, we talked about domain and range. So you see you have arrows on both sides, correct? So as I go from left to right, you notice that the domain is all real numbers. Domain's all real numbers. And the range, in fact, is also what? All real numbers. So the range is all real numbers as well. All right, so these are all things that you can integrate from what you've learned in previous lessons. Okay, so let's talk about this again. So since the slope is positive, the line rises from left to right. Okay? And other way we can say this is this way. Now listen carefully. So we know that our line rises from left to right, correct? Now I want you to notice as I go from left to right in terms of the domain, so from negative infinity to infinity, I want you to tell me what's happening to those y coordinates. All these y coordinates, you see they're getting larger and larger? They're increasing, right? So if you look at this y coordinate, that's 5. If you look at this y coordinate, that's 8. Those y coordinates are increasing. All right, so another way we can describe this line, is to say that the line is increasing. All right, so the line is increasing. All right, so anytime you have a line with a positive slope, we can also say the line is increasing, meaning that the y coordinates are increasing. So basically this means this. The y coordinates are increasing. That's basically what that means, okay? The y coordinates are increasing in value. So this number, this y, the y coordinate at this point, the y coordinate at this point, the y coordinates at this point, see they're getting larger and larger and larger, those y coordinates. All right, so let's look at another, and we'll come, and also notice that the topic here is linear functions, right? So linear because they're lines, so we are talking about lines, but functions, remember the definition of function? For each x coordinate, there's only one y coordinate. And I want you to notice this is a function, right? Because it passes the vertical line test. So so these lines that we're talking about, for the most part, except one of them, will be functions. So these are all functions. Okay, let's look at another problem. So this is number 1. Let's look at number 2. In number 2, let's suppose we had this for number 2. We had, all right, let's say we had this. So let's say we had -3, 9, and let's say we had 2, -5. All right, so -3, 9, and 2, -5. And if I just go ahead, remember all I want to do is just find the slope. So if I just go ahead and use the slope formula, remember the slope formula is y2 minus y1 over x2 minus x1. And then let's go ahead and label this x1, y1. So here's my first point. So that's the x coordinate of my first point, the y coordinate of my first point. And then this will be the second point. So we'll call this x2, y2. And all you do is just substitute into this formula. So the slope of this line that contains these 2 points is going to be, and let's start with y2. So we're going to say -5 subtract 9. Make sure you do this correctly. Some students get the the coordinates mixed up. Remember, it's the y coordinates. So -5 subtract 9 divided by, if I started with -5, I must start with 2. So 2 subtract a -3. So the numerator, if you look at this, -5 subtract 9, that means the same thing as -5 plus the -9, so that's a -14. The denominator, 2 subtract a -3, is a +5. So there's a slope. Notice this time the slope is negative, right? So notice the slope is negative. So let's remind ourselves what that means, since what it means for the slope to be negative. So let's go ahead and plot those 2 points and just look at the graph and kind of look at what we have. So if I plot those 2 points, so we had the points -3, 9, and 2, -5. So -3, 9 is here. -3, 9 right here. So that's a point -3, 9. And also 2, -5. And so 2, -5 is here. So, okay, so I have y'all can see this in this part. Now, I'm going to need a bigger ruler than this. So let me see if I can quickly find the ruler. Obviously I can't, so I'm going to have to use this small one as best as I can. So I'm going to go ahead and graph this line. Oh, it'll work. All right, so let's go ahead and graph this line like this. And so make sure you draw your arrows. All right, so there's the line. And I want you to notice that as you go from left to right, you see the graph is falling. All right, so remember in this graph here, we said the graph was rising, right? The graph was rising. Here, if you compare them, the graph is falling. The graph is falling. Remember a while ago we said here my y values are increasing. So if the graph rises, that means your y values are increasing. If you notice here, what's happening to these y values? These y values are decreasing. They're getting smaller and smaller and smaller, aren't they? So you see this y value looks like it's 6. This y value looks like it's somewhere around 3. This y value looks like, let's use this one, somewhere around -3. You see they're getting smaller and smaller and smaller. They're decreasing. Okay? So what I want you to remember about a line that has negative slope is this. So the slope is negative, so that means that since the slope is negative, since the slope is negative, the line falls from left to right. Okay? So the line falls from left to right. So as you go from left to right, as you go from left to right, the line falls, which means that these y coordinates are decreasing. So remember when we talked about this, the positive slope, remember, since the slope is positive, the line rises from left to right, which means that the y values are increasing, so the line is increasing, which means the y coordinates are increasing. Here, we're going to say this. Since the line falls from left to right, that means that the line is decreasing. The line decreases. Let's put line decreases. Which means this. The y values are decreasing, becoming smaller from left to right. Okay, so that's what that means. So the y values are decreasing from left to right. They're becoming smaller from left to right. All right, so positive slope, the line rises. The y values are increasing. Negative slope, the line falls. The y values are decreasing. Okay? All right. Now, here's something else that you talked about when you dealt with slope. So let's look at number 3. So let's suppose at number 3 I have these 2 points. Let's say we had negative. Let's say we had -2, 3, and let's say 4, 3. So let's say we had those 2 points. So -2, 3, and 4, 3. Okay. So So if I go ahead and find the slope using the slope formula, so remember the slope formula is y2 minus y1 over x2 minus x1. So let's call this x1, y1. This will be x2, y2. So I'm just going to substitute into the formula. And so when I do that, I'm going to get the slope to equal, remember, we're going to start with y2. So that's 3. So we're going to say 3 subtract 3 divided by, and then you're going to subtract the x-coordinates. So we're going to start with 4. 4 subtract a negative 2. The numerator is 0. The denominator, 4 subtract a negative 2 means 4 plus 2, so that's 6. But you got to remember this. You have to remember that 0 divided by 6 is 0, so you must say 0. Okay? You must say 0. And so the slope is 0. So let's kind of remind ourselves what that means when we have a line whose slope is 0. So I'm going to go ahead and plot those points in this plane. So negative 2, 3, and 4, 3. So negative 2, 3 is here. 4, 3 is here. I want you to notice that when I draw that line, that is a horizontal line, right? That's a horizontal line. And it's still you remember that it's a function. It's still a function. Passes the vertical line test. All right. So this horizontal line has slope 0. So what you learned, slope is 0. What you learned when you studied this topic in a previous course was that all horizontal lines have slope 0. Okay, so there's a slope. It is 0. Okay, it is 0. So whenever you have slope 0, then it's a horizontal line. Okay. Now, here's something else you have to know. So remember when we looked at our first graph, we said that this line was increasing, right? And it was increasing because those y values are increasing. They're getting larger and larger and larger. Okay? When we talked about this, we said that these y values are decreasing. So a line that falls also means that it's decreasing, which means that those y values are decreasing. Okay? Now listen carefully to this line that's horizontal. Let's talk about those y values. What do you notice about the y value here, the y value here, the y value here, and so on? What do you notice about them? So let's think about the y value. So I'm going to go ahead and label this point. So this point here is negative 2, 3. This point here is 1, 3. This point here is 3, 3, and so on. So if you look at all of these points, any point on that horizontal line, what do you notice about these y values? They're the same. They're constant. Those y values do not change, right? So if you look at the line here, those y values are changing. They're changing. They're getting bigger and bigger and bigger. If you look at this, those y values are changing. They're getting smaller and smaller and smaller. They're decreasing in value. Whereas over here, they're not changing. They're not changing at all. They're staying 3, 3, 3, right? So what that means is this. So a horizontal line, remember, has slope 0. We also say this. We also say that a line with slope 0 is constant. A line with slope 0 is constant. All right, which means this, which means that we can also say that it is a constant function. It is a constant function. Okay, it is a constant function. So over here, when we said that this line here was decreasing, we could have also said this. We could have also said this is a decreasing function. This line, well, we could say this is a decreasing function. So this function is decreasing. This function is decreasing. Okay? Over here, when we did this one, the one that had positive slope, we could have said We could have said this function is increasing. All right, which means that it's an increasing function. Okay, so here's the takeaway from this so far. A line with positive slope, is an increasing function. Okay, so it increases from left to right. So as you go along your domain, from left to right, so as I go from negative infinity to positive infinity, my y values are increasing. So this is an increasing function. Here, as I go from left to right, this is a decreasing function. Here, as I go from left to right, it's constant, right? So that's a constant function. So a line with slope 0 is a constant function. All right, now, one more thing I need to remind you about, and that's this one. So let's look at number 4. Number 4, let's suppose we had this. Number 4. Let's suppose we had the points 4, 6, and let's say 4, negative 2. 4, 6, and 4, negative 2. Okay? So let's go ahead and use the slope formula to find the slope. So the slope will be, so let's call this x1, y1, x2, y2. So the slope will be, and let's start with negative 2. So we're going to say negative 2 subtract 6, right? Divided by 4 subtract 4. And so I get negative 2 subtract 6 is a negative 8. 4 subtract 4 is 0. Now you got to remember something you've learned in the previous course, that whenever you divide by 0, whenever you have the numerator being a non-zero but the denominator being 0, then we say this is undefined. Okay? Now what that means is this. That means that this line has no slope. That's what that means. So rather than saying undefined, sometimes we prefer that you say that this line has no slope, which means the slope is undefined. No slope. All right? So a line that has no slope, let's look what the graph looks like. So if I plot those 2 points, 4, 6, and 4, negative 2, so 4, 6 is here, and 4, negative 2 is here. Okay? If I plot those 2 points and then draw the line, I want you to notice that this line is vertical. It's a vertical line, right? So a line that's vertical has no slope, which we can also say the slope is undefined. Okay, slope is undefined. All right, so let's go back. I'm going to come back to this in a little while. Let's go back here. So this line has undefined slope or no slope, which means that this is a vertical line. This is a vertical line. So remember what you learned in the past was that all vertical lines have no slope, which means that it's undefined. Okay? All right, now, here's the thing I want to remind you. Remember, we're talking about linear functions, right? Talk about linear functions. Well, remember, this vertical line fails the vertical line test. So I want you to remember that this is not a function. So this is not a function. So all the other lines are functions. So lines that rise are functions because it passes the vertical line test. Lines that fall or lines that decrease are functions because it passes the vertical line test. For each x coordinate, there's only one y coordinate. For this x coordinate, there's only one y coordinate. For this x coordinate, there's only one y coordinate. Horizontal lines are functions because it passes the vertical line test. For each x coordinate, there's only one y coordinate. When x is negative 2, the y value is only 3. When x is 4, the y value is only 3. When x is 3, the y value is only 3, and so on. But when we look at vertical lines, that's not a function because it fails the vertical line test. Because I want you to notice, when x is 4, my y value is 6. But also when x is 4, my y value is 5, right? So for this x value of 4, there are an infinite number of y values. The definition of a function says that for each x coordinate, there's got to be just one y coordinate. All right, so this is not a function. All right, so this basically was a review. This was a review of finding the slope of a line given 2 points. All right, and just make sure you understand that that this is increasing. The line rises, slope is positive, it's increasing. Here, the line falls, so my y coordinates are decreasing, so this is a decreasing function. Here, I want you to notice that my y values are constant, so this is a constant function. My slope is 0. All right, and remember, vertical lines are not functions, so those are not functions. So all other lines are functions except vertical lines. So vertical lines have no slope or undefined slope, that's undefined. Okay. All right, so that is going to take care of our lesson. And remember, this is just a review of slopes.